Friends, I'm Sudhanshu and I welcome you to this video. In this video, I have covered one of the important topics of networking, that is network time protocol. Time is very important in any network. In this video, you will learn about NTP concepts, its working, why we use NTP networking and its importance. In this video, we have also demonstrated the NTP labs and you will also learn how to configure and verify NTP. So let us get started. Also, I would like to remind you one thing. If you have any difficulty in understanding any topics during the video, do share your questions in the comment section. So let's begin.
It's a very important protocol, but often the most neglected one by beginners. Why is it important? Let's first understand that. What's the purpose of the network time protocol? We want to synchronize time across different networking devices, whether you have a router, whether you have a switch or a firewall or any other device, we want to synchronize time. Why is time and time's accuracy important? The accuracy of time is important because let's say something happened to this router, which we had in our production environment. Now, if I pull out the log and let's say all the logs have wrong timestamps, like I will never get to know when the router interface went down or when something happened with the router, right? Because if there is a wrong timestamp, it will not allow me to judge what happened when in the router. So the accuracy of time is very, very important, right? And apart from that, there are many other things that require time. One of the other things is sometimes we use some things based on some, let's say, rules based on time. What I mean by that is, let's say we are having a college campus and we have made certain rules that anybody who is a college student, okay, they will not be having access to social media during the college hours. Okay, so if that happens, now we want that during time, maybe 10 a.m. to whatever 4 p.m. let's say that's the college time, then we don't want people to be allowed to open social media during that time, right? And this is again time based. So sometimes we have time based rules, sometimes we have some form of authentication based on time, like maybe we have some accounting servers, okay, and we want that these should be accessible only during office hours. Okay, so we have some time-based restrictions to allow access to these servers only when there are office hours. These kind of things are not possible until you synchronize time. And to synchronize time, we use network time protocol. So just like I told you that routers, switches, pretty much every device known in the IT world has a time of day clock. And it makes sense to synchronize these clocks so that every device has the same time of day. And there should not be any difference other than the difference of maybe a time zone. Like obviously a device in Indian time zone will definitely have different time than something in maybe US, right? So that difference will be there, but we don't want any other difference. Now, with NTP servers, we supply time of day to clients. Okay, so we configure devices as NTP server. All the devices that we configure as NTP server will serve time. Means they will be sending packets in which they'll be sending information about time to NTP clients. Okay, now who will be client? It could be router, it could be any server, it could be a firewall, and we can configure some device as an NTP server. Okay. Now, this is also an application layer protocol, just like many other protocols that we have learned in CCNA. Now, this one uses UDP port number 123, and it requires repetitive small adjustments of time so that the time synchronization can be maintained, because we don't want any time differences between any devices. So what we do is configure one device. Like it is typically done in this way that before you make some device, let's say I'm taking a router and I'm planning to make it an NTP server. Now, before I make it an NTP server, it makes sense to set the time accurately by looking at some trusted source. Okay, maybe like I'll synchronize this time with by looking at some trustworthy source. Okay, so once you synchronize the time, then you can ask your NTP server or the device acting as NTP server. Even router can act as an NTP server and then provide time to others. So before starting NTP on a router or a switch, make sure you synchronize or set the correct date and time zone, and even tell the device to adjust for daylight savings time. This is a concept that is very popular in US. What they do in this daylight savings time is their clocks 1 hour forward or 1 hour back to best utilize the daylight. Okay. Now this was actually built at the time when we didn't have things like electricity, but this tradition has been continued for quite a while now, so it still continues. Now, how do I configure time zone on a router, and why do we need to do that? Think about it this way. Let's say I have a router in Delhi, India, and I have a router here, maybe in New York. Okay. Now, obviously, the time zone for this device will be different, and the time zone for this device will be different, right? So we can configure time zone on any device by giving these commands of clock time zone and then telling an indicator of the time zone and then telling the offset how the value differs from the universal time coordinates, okay, or the GMT time. So for India, we have plus 5:30 hours, okay, 5 hours 30 minutes. That is the Indian Standard Time. Similarly, different countries have different. So we can set that. Apart from that, we can also give the command of clock summer time recurring. This will tell about the daylight thing that I was talking about. So once you set this, you have educated this router, Mr. R1, where which time zone it follows. What happens is whenever you get time from NTP server, NTP server is going to give you time always in universal time coordinates. That means the Greenwich Meridian time. Now, what you are going to do is you are going to take that time. Let's say you are a router and you have been configured with this thing. So -5, you will subtract 5 hours and set your own time. Okay, clear? So moving on, if we talk about the basic NTP configuration, Cisco gives you two commands, two very important commands here, through which you can configure NTP. The first command is NTP Master. Okay, let's first understand the meaning of this command. This command, NTP Master, is used to make a device act as NTP server. Okay. So what we are telling with this command is that whatever device you have, maybe you have a server, maybe you have a router, that device, you're telling it that obviously it's a Cisco device. Okay, so because we are talking about NTP configuration commands on iOS, so NTP Master here means that this device is going to act as a NTP server. Okay, so that's the first part. Now, the second part or the second configuration command that we have here is NTP Server. Okay. Now, before I go into NTP Server command, the second command, let me tell you what is this Stratum level. Okay. With this NTP Master command, you have an option to define a Stratum level. Think about it this way, that to have different accuracy levels for time, we have built something called a stratum. Now, the most accurate device for providing time in this world we have is atomic clock. Okay. And these are big bulky devices which are very accurate in keeping measurements of time. So I'll not go much into it, but like if we go and see, these atomic clocks are used for monitoring. It measures time by monitoring the frequency of radiation of atoms. So it's a very high tech way calculating the time differences. So the main thing is in years of time, it changes. There's a very small deviation that happens. Okay. In these type of clocks. Now, for these type of devices, what we do is we call them, if let's say there is a device which synchronizes its time from an atomic clock, we call it a Stratum 1 device. Okay. Now, think about it this way, that let's say there is another device who wants to synchronize time. Now I'm just drawing boxes here. So don't think this is a router switch. Any device which utilizes NTP protocol, I'm taking it in general. So let's say this device here synchronizes its time with device A. Now this device A will be acting as a NTP server, and this device will be acting as a NTP client. One who asks for the time is called an NTP client. One who gives time is called NTP server. Now notice, I'm not saying that these two devices are nearby. Like let's call this device B. I'm not saying that device A and B both exist nearby. Okay. There might be a huge distance between them. There might be a lot of routers. But if we know that B is synchronizing its time with A and it's a Stratum 1 device, if it becomes an NTP server and gives somebody else time, then it will increment the Stratum number. It will say, I am a Stratum 2 device. Okay, you getting the point? So it's not like we are counting the number of routers. Okay, there may be 4, 5, or maybe 50 routers in between A and B. Okay, but based on if B synchronizes its time with A, which is a Stratum 1 device, if B becomes an NTP server and supplies time to others, it will say, I'm a Stratum 2 device. Okay. Now, whenever you have any other device, let's say a C device taking time from B, if you configure it with multiple NTP servers, which you can educate the device C about an NTP server B and A. Which one do you think it should prefer to synchronize its time? Obviously, the device A will be preferred. Why? Because this is more accurate time source. Okay, you get the point why they have built this concept of Stratum level. The main aim is to ensure that devices which are acting as NTP client, when they pull time from somewhere, they should know which device is more accurate. So that if they have, let's say I tell multiple NTP servers, I configure that C device with multiple NTP servers, and one of the devices that I'm telling is a Stratum 2 device, another is a Stratum 4 device. It will prefer a Stratum 2 device. Okay. So that is the main aim of having this Stratum. So this is the first command that you give generally to configure a Stratum and configure the device, that Cisco iOS device, as a NTP master, basically becoming an NTP server for others. Now the second command that we have is NTP server. And in this command, we mention either the IP address of the device with which the this device is going to synchronize time. So let's say I go to a device, a router A, and I give the command NTP server and then 10.0.0.1, let's say. Then I am telling device A that Mr. A, synchronize your time with this device. Okay. Now it's not necessary that we just give IP. We can also have the option of giving a name. If you give a name here, a host name, then you have to ensure that there should be DNS servers available through which it can utilize, it can resolve the name to an IP, because that is only when this device A can synchronize time with that device. So you have the option of either specifying an IP address or you have the IP information about host name. Now, notice one thing. With this command, you are making it only an NTP server. Okay. With this command, you are not making it as an NTP client. But with this second command, you are making it as a client and server both. And this is, I've found sometimes people don't know this. Okay, most of the people think that when you are configuring NTP server, that means the device will act just like a client and pull time from somewhere. Whereas in the actual things, this device acts as a client as well as a server, both. Okay. So it will synchronize time with this IP address or this host name, and then it will act as an NTP server if somebody synchronizes its time with this device. Okay, clear? Now, if you do this NTP master and give the stratum level, then you are basically asking that device that keep your internal clock ticking, because just like you may have seen that even PCs, they remember time because they have a battery, a small battery in them. This kind of small batteries there in even laptops and PC. So this battery ensures that your laptop doesn't forget its time. Okay. So these kind of things are available even in your routers. Okay. So when you power off the router, it can keep track of the time that it has. So if in case you use this command of NTP master, then this device will utilize its internal clock to keep track of time, because you have not asked it to synchronize time with some other source, external source. Okay. So it will use that internal clock and supply time to others. Okay. So just to be clear, let's take this example. If you look at this diagram here, we have router R1, we have router R2, and we have router R3. Now in the R3, we have given the command of NTP master. In the router R2, we have given the command of NTP server, and then an IP address which belongs to router R3 here. So finally, if you look at this R1, we have given the command of NTP server and told the IP address of R2. Now, if we give this R3 as NTP master, it will act just like an NTP server, not an NTP client. And this R2 device will act like a client and server both. And if the stratum is configured here as 2, this device will become stratum 3. And this device will become stratum 4 because it is synchronizing its time with the stratum 3 device. So I hope the concept of stratum is also clear. Now, although in this diagram, we have these routers directly connected with each other, but don't think that this is something called a hop count. Okay, this is not keeping a count of routers. Okay, because there may be 2 or 3 routers in between. But if R2 is synchronizing its time with R3's IP, it will become only Stratum 3 device. Okay, just to be clear, I've seen a lot of times people considering this as hop count, means how many routers it has to cross. It's not related to that. This is a different concept of Stratum. So the configuration will be pretty straightforward. This will be a configuration on R1. This will be the configuration on R2 and configuration on R3. Now, another very important point is that NTP is a very slow protocol. Okay. So keep this in mind when you're doing practicals, because if you try to utilize NTP commands and try to quickly cross-check and verify things, sometimes it's going to take time, a lot of time, before it can successfully synchronize its time. Okay, and its purpose fully built that way. Okay, the reason for building NTP this way is that if in case, let's say, this device is changing the time that it sends to others very frequently, then this device, which is acting as a client and pulling time from this server, will not trust the time if this device acting as server changes time very frequently. So that is why whenever you update the time, sometimes it will take some time before it synchronizes the time. Okay. So for verification purposes, we have the command of show NTP status, which shows you that whether the clock is synchronized and what is the stratum. Like in this case, this is from R1's output, and who is acting as a NTP server for this device of R1. So it's 172.16.2.2. That is this device acting as a NTP. Okay. Acting as an NTP server. Apart from this, you can also use the command of show NTP associations. The good thing about this is, if in case you have configured, let's say, R1 for multiple NTP servers, let's say there is device A, device B, device C, then you will see all of those entries in the NTP association. And with one of them, you will see it synchronizing time. Like in this case, it is this particular 172.16.2.2 with which R1 is synchronizing time. Now, similar thing, if we check at R2, what you see is show NTP associations and the IP address of R3. Okay. So let's look at this practically. Now, there are these commands are a little bit less supported on packet tracer. So I tell students that preferably do this practical either on a real router or an emulator like GNS, if in case you want to put a lot of commands. Which some of these commands that I'll be entering may not be supported here. Okay, so I'm not sure about NTP configuration on the packet tracer, and but this is sufficient for CCNA level. Okay, I'm not saying that CCNA level guy should go and go for these GNS and even G and these other simulators that are required. Generally, this is sufficient. So let's configure a very simple topology. I will configure 3 routers. Let's say R1, R2, R3. Okay. And we will configure them in the same way. Okay, this one is R3, this one is R2 and R1. Now, before configure NTP, just make sure the IP reachability is successfully available between the devices. Okay, so I've seen sometimes not having IP reachability and then thinking that their NTP is not working properly. So just I've already discussed how to do static routing, so I don't think I'll need to explain that again. So here, let's go to R3. And this router, I will configure first with an IP address. I'm using the same IP addressing. Let's give a host name of R3, interface gig 0/1. Sorry, 0/0/1. Okay, and IP address 172.16.3.3 /24. No shut. And interface gig. Okay, not required at this router. Now here, this is where we will configure the command of NTP Master. Okay. If you see after NTP Master, you can mention a Stratum level, which depending upon your device, if you are acting as an NTP server, you can define a Stratum level. Let's say in this case, I will define Stratum as 2. Okay, I forgot to do it earlier. If you don't define an NTP, if you just plain enter NTP Master command and don't define the Stratum, I've seen in many iOS, it takes a Stratum of 8, which is considered not so accurate source of time source by many operating systems. So preferably don't do that. Now, actually, before we did this, we should have properly configured this with a time. So here, let me set the time of the router. And you can cross check show clock, and preferably, when you're setting this time, let me give you another tip here. Like this is the Indian time currently. You should not set Indian time. You should set the GMT time or the UTC time. Okay, like currently the GMT time is, I should have configured it to 10:30 AM, 4th July. Okay. Now, if you do show clock, you see currently it shows you UTC here, right? UTC means Universal Time Coordinates. And if I go here and want to, let's say this device exists in India. So I should go and configure the clock time zone and say Indian Standard Time, and then tell the offset. Like in India, we have offset of 5 hours, 30 minutes. If in case it is in minus, you should add a minus in front of that. Okay. So for me, it is plus 5:30. So I am telling that. And if you double check the time now, you can see that now it is properly accurate time from Indian Standard Time point of view, because earlier I had not configured this router with a clock time zone command. All right. So if we do show NTP status, what you see is that clock is synchronized and Stratum is 2. The reference that it is utilizing is a loopback IP. That means this router is not taking its time from some external device. It is using its internal clock to synchronize its time. Okay, so I think that's sufficient configuration. Let's go to the next router, router R2. And let's first configure this router with an IP address on interface gig 0/0/1. So interface gig 0/0/1. And here I will set IP address from a similar range, 3.2, let's say. Shut. And also let me set the host name. Now in this one, we can say NTP Server 172.16.3.3. That is the IP address of R3 here. Now, do I need to configure any routing for this? The answer is no. Why? Because this is a directly connected network. So even if I try to ping this IP address, you can see the IP address is reachable. So here, if I check show clock, currently the time is not synchronized. It's showing as 1993. Show NTP status. You see clock is unsynchronized. And that is why I told you that this is a slow protocol. So we will have to wait a bit. As we can see, the reachability is there. And obviously that R3 is set for working as an NTP server. We already did that. So while we wait, let's go and configure the other router. Save the configuration. And okay, we need to configure the other interface here as well. So let's do that. I forgot to configure that. So interface gig 0/0/0 IP address 172.16.2.2. Shut. So finally, I'll go to R1. And on the R1 router, again, first thing, let's set a host name. Interface gig 0/0/0 IP address 172.16.2.1, let's say. So again, because I want my R1 to synchronize time with just R2. So the reachability thing is already there because of directly connected network. Let's try to just double check that with a ping. And now in the R1, we can say NTP server and say 172.16.2.2. That is the IP address of R2. So I think by this time, the R2 should have synchronized its time. So let's cross check. You can see now the clock is synchronized at R2. And it is important for R2 to synchronize its time, because if R2 is not able to synchronize its own time, it will not act as an NTP server and give time to others. And we can cross check now, do a show clock, and we see a correct time. Now, let's say this device is in some other time zone. Let's say this device is in US. So then I will give the command of clock time zone. Let's say Pacific Standard Time, and I'll have to double check how much offset it is. So that is -8 based on quick Google search. Wait. Clock time zone, Pacific Standard Time, -8. And if in case like in US, there is this daylight savings time which is followed, then we have to give the command of clock time zone. And sorry, clock. Okay, that command is not supported here probably. I was trying to give this command of clock summer time. So that is not supported here on packet tracer. Anyways, no problem. Let's ignore that for now. So we can cross check if we do a show clock now. The time that is shown is 2:37. So finally, let's go and cross check with R1 and say show NTP status. I think by this time the clock should have synchronized. So clock is synchronized, and you can see references 170.16.2.2. Now, thing that you should ignore in packet tracer when you're doing this practicals at CCNA level is, see here, the R2 got time from R3, right? So based on that, the stratum should have become what? Stratum should have become 3, because the R3 has a stratum of 2, right? But I don't know why, or I think this is probably a bug that although R2 is synchronizing its time with a Stratum 2 device, it shows here as Stratum 16. So please ignore this part if you're doing this in a in packet tracer. If you do this in GNS or real routers, it will be just like Stratum 3 here for R2 and Stratum 4 for R1. Okay, so if in case you are thinking about why Stratum is not showing properly, please ignore that. This is a packet tracer bug. This is not some issue with iOS. Don't try to fix this. Sometimes because of all these reasons, because there are some of these bugs, I feel like writing a book, 101 reasons why not to use packet tracer for your CCNA exam preparation. Okay, because for a beginner who has not understood the protocol completely, this can be misleading and this can lead to a wrong understanding. So some of these things can bother sometimes the beginners. Anyways, moving on, we have already checked the NTP configuration. Now, I already told you that NTP servers and clients use a number to show the perceived accuracy of their time, and that is called stratum level. The lower the stratum, more accurate the reference clock is considered. I already discussed this. And an NTP server that uses its internal hardware or external reference clock sets its own stratum level. Like I told you that we could have given NTP Master 2, 3, 4, whatever we want to mention here. Any NTP client that synchronizes time with, let's say this is Stratum 2 device, it will say I'm a Stratum 3 device and supply time to others. So it adds a Stratum level, tell how far away Stratum 1 device is. Okay, and the more NTP master is away, NTP server is away, you will see a bigger Stratum number. And routers and switches by default, like I was telling you, that if you don't mention this, because this is an optional thing to configure, you could have just given an NTP master command and pressed enter. If you do that, then the stratum level of 8 is taken, which is considered not so accurate time source. So preferably, you should mention some stratum level. I know a lot of operating systems who don't even synchronize time with some NTP server if it is supplying Stratum 8 time. So with this NTP master command, you can set a value anywhere between 1 through 15. 16 is considered as time data unusable. 16 is totally considered not trusted at all. We can cross-check, show NTP status on R3. Reference is local, just like we saw in the practical that we performed. Also in the NTP associations, I'm not sure whether this command works in packet tracer or not. Let's quickly check it. Show NTP. Yeah, okay, this works. So it shows you show NTP associations. Fine. Now the next part about NTP. Preferably from design point of view, it is recommended that we should not configure our every device to go and take time from some public NTP servers. Okay. So if you want to synchronize time, there are devices and people who will give you time for free. I mean, NTP messages for free. And there are websites where you may need to purchase NTP services. So if you look at this pool.ntp.org, this is a cluster of NTP server. And you can use this to synchronize time if in case your company wants to synchronize time. So you can, if in case you are using a Linux, you can do it this way. So for a router, you just have to mention maybe server0.pool.ntp.org or server 1. And these this way you will configure your devices to synchronize time from these NTP servers. Preferably synchronize time from some trusted sources, okay, like maybe NIST servers. So let's say this is our company network. Now we don't want every router to be going out and synchronizing time with the public NTP server. Okay. So what we do is we preferably dedicate one, or preferably for redundancy purposes, we dedicated 2 devices who will go out and synchronize their time with public NTP servers. Once they synchronize time, they will act as NTP servers for all the devices that are within our corporate network. So this is the design strategy generally which is followed. And the reason for keeping 2 is just so that if this device goes down, we don't want our time to be unsynchronized for these devices in the corporate network. Okay. So I hope you get the point, like what we mean by the NTP design, how it should be. Okay. So an enterprise could use NTP to reference NTP servers that use an atomic clock. You could use them as your primary NTP servers. Like I told you, for a good design, configure at least 2 external NTP servers for redundancy. So just like I showed you, server 0.pool.ntp.org and server 1, server 2, and server 3, you could do that. And not every device should go out and refer those NTP servers. You should synchronize only these devices, some 1 or 2 devices to work as a NTP client, pull time from public NTP servers. Majority of these devices, other devices in the enterprise, would act as NTP clients and synchronize time with these devices, which are fetching time from outside. Okay, one thing that we need here. Let's say, because of some reason, in this scenario, we lose connectivity to internet. Okay, for both R1 and R2. Now, in this case, if you lose connectivity to internet, these devices may feel as if they don't have a synchronized time. Okay. So what we can do is we can configure these devices, this R1 and R2, in such a way that they keep their clock ticking so that they can at least supply time to other devices. So for that purpose, what we have is we want to give this command of NTP Master. Okay. So with this command, the benefit will be that even if they lose connectivity to these external servers, they can still supply time to others because they will utilize their internal clock to supply time. Okay. So in these R1 and R2, basically, we are going to configure an NTP server command with which we'll be referencing these servers, these public NTP servers. And apart from this, we will put another command in this R1 and R2 here, which is NTP Master and a Stratum number. The benefit of this second portion of configuration is if in case they lose connectivity to internet and they lose connectivity to these public NTP servers, they will still keep on taking their time using the internal clock and supply time to other devices. Okay. Now, when you're configuring this NTP master command with the Stratum number, you should configure the Stratum number, which should be higher than these public NTP server Stratum, because we want that this time should be preferred, right? If in case the internet is all working fine and we have reachability to these servers, then we don't want to utilize the internal clock of these devices, right? So if you configure, let's say these public NTP servers are Stratum 1, if we configure NTP Master and a 2, the benefit will be if in case these servers are reachable, up and running, then it will never use its own internal clock. It will use these servers. If in case it loses connectivity to Stratum 1 devices, which are outside the enterprise, then it will use its own internal clock and will keep the time ticking. I hope you get the point, like how this all is working. There is another thing that I want to talk about here, and that thing is related to loopback interface. Now, I have discussed earlier that we use loopback interfaces, which are logical interfaces, right? These don't exist physically. You can make lots of loopback interface. And I told you there are two main reasons why you would create a loopback interface. One of the reasons that I told you was that if in case there is some critical communication that a router has to initiate with maybe other routers or any other device, then we can ask the router to generate the packets using the source IP of loopback. Okay. We will understand that scenario here in this example. Let's say this is our network and we have R1, R2, R3, and R4. So we have these 4 different routers, and let's say this R4 is the device which is acting as an NTP server. Now, let's say we want to configure NTP, the R1 router, as an NTP client. How can we do this? We can configure R1 with the command NTP server and then IP address of R4. And assuming, let's say the IP address here is 10.0.0.1. Let's say the IP here is 10.0.1.1. And the problem is, if I configure R1 with an NTP server of 10.0.0.1, what will happen? R1 is going to go and send requests for time to pull time using this IP. The destination IP for those requests to pull time will be 10.0.0.1. And R4 will be giving time. There will be no problem in this scenario. But let's say now, because of some reason, this interface goes down. Okay. At this moment, if R1 tries to send requests to this IP address, there is no way that R4 can respond because this interface is down. Okay. In fact, if you try to even do a ping of 10.0.0.1, although there is an alternate path to reach R4, but still R1 will not be able to ping this IP. And similarly, not even get time from this R4 router. Now you understand the problem here. How can we fix this? If we go and configure this R4 with a loopback interface, let's say loopback interface 1, okay, interface loopback 1, and we configure this IP, this interface with an IP of, let's say, 10.10.10.10. And now what I can do is I can ask R1, instead of configuring it this way, I can say, Mr. R1, NTP server is 10.10.10.10. Now, the good thing about this is R1, whether it takes this path or whether it takes this path, it is always communicating with the loopback interface. So even if this physical interface goes down, will R1 be able to pull time from R4? Yes, right? At the same time, even if, let's say, this interface stays up and this interface goes down, will R1 be able to still pull time? Yes. Okay. So you understand what is the benefit of using a loopback interface? You are having better availability. And this is what I meant when I was discussing the loopback interface use. That the benefit of using a loopback interface is, if there is the router which is up, doesn't matter whether you take this physical interface to reach it or whether you take this physical interface to reach it, you will still get the service of loopback. You will still get the service of time from R4 acting as NTP server. So this is the benefit of utilizing loopback interface for NTP server. Now, I told you an NTP server will accept NTP messages arriving to any of its IPv4 address by default. So R4 will accept NTP messages coming from 1, 2, 3, whichever interface it comes from. Okay. However, there is an availability issue if you reference this physical interface, because if the physical interface is not available, the NTP clients won't be able to communicate with R4. What is needed is a way to send a packet to R4, a way that is not tied to the state of any one physical interface. That is, as long as there is some path to send packets to R4, we want to allow NTP to keep working. So that is why we avoid using these physical interfaces here. And rather than using them, we can use and create a loopback interface on R4 for the same thing. I hope this clarifies this. Now, this also requires a little bit of configuration for the NTP server device. So on R4, apart from configuring the loopback interface, which you already know how to configure a loopback interface on a router, you will be giving a command of NTP source loopback and the loopback interface name. So with this command, we are telling that this R4 device is acting as an NTP server, and whenever it sends NTP messages out, doesn't matter whether it uses physical interface 3, 1, or 2, whichever physical interface it uses, it should always use the source IP of loopback 0. That is what this command is saying. Okay. So it will always use the IP address of 172.16.9.9 whenever it's supplying time to anybody asking time. Okay. Obviously, on R1 part, the configuration will be that we will be configuring it as NTP server 172.16.9.9. Okay. So that concludes the topic of NTP. Thank you very much for listening patiently.